Hey folks, so this is going to be a video that deals with the graphs for secant and the cosecant parents. I personally like to cover the cosecant parent first. So we understand that cosecant of x is the same thing as 1 divided by the sine of x. This is according to our reciprocal identities. And because I have a denominator that could potentially equal 0, this also means that I'm going to have undefined places on my graph, aka asymptotes, vertical asymptotes. So what you want to do is you want to go to your unit circle and you just want to ask yourself from your unit circle, at what places on your unit circle does your sine value equal 0? Because wherever your sine value is equal to 0, that's going to cause an undefined place on your graph. All right, so when you go to your unit circle, if you look at the position of 0, pi, and 2 pi, all three of these have a sine value of 0, which means that my cosecant value is going to be undefined. So these are the three main ones that I'm going to be paying attention to. Now, our period is going to be the same as our sine function was. So if we get our 4 equal intervals and we go out to 2 pi, half of that is pi, half of that is pi over 2, and then we can count 1 half, 2 halves, 3 halves, and 4 halves. Now, so when we go and draw our asymptotes, we've got an asymptote that is going to occur on the y-axis, one that also occurs on pi, and one that occurs on 2 pi. And if you hear something weird, I do not have mice, but my puppy is deciding to chew on his bone right now, and that was about the only way I could keep him quiet. It's not totally quiet, but I apologize for that. All right, so I have these asymptotes that are occurring basically at the beginning, the middle, and the ending of my period. Now, I need a few more values to be able to fill in the blanks. And so when we look at the sine value at pi over 2, that's going to be 1. So 1 divided by 1 is 1. So at pi over 2, I have a value of 1. Let's go ahead and mark our 1 and our negative 1 on the y-axis. And at 3 pi over 2, my sine value is negative 1, so the cosecant is going to be also negative 1. And I could plug in a few more values. You can see in the table up there that you've got pi over 6, etc. But basically what happens is your cosecant graph is going to be, they look a little bit like parabola shapes. They are not parabolas because these guys are fenced in by our asymptotes, and parabolas keep getting wider and wider and wider. So these may look a little bit like parabola shapes, but they are not true parabolas. So then you notice that I've got one full period drawn here of my cosecant graph. Now, I could go in really lightly and I could map out where the original sine graph would have been. So essentially what you know here is that if you look at where the asymptotes are of the cosecant asymptotes are always going to occur at wherever my sine had x-intercepts. In this case, it's at the beginning, the middle, and the ending. Not only that, you'll also notice that the maximum of your sine ended up being the minimum of your cosecant. Now, this just ends up being a relative minimum. It's not an absolute minimum, but it's a minimum in its own little neighborhood. And then lastly, the sine minimum ended up being the cosecant maximum. All right, so that's going to be the parent graph of your cosecant. I don't need that green guy in there. I don't need the sine in there for the cosecant graph to be complete. All right, so then if I use the same concepts for secant, I know that secant of x is equal to 1 over cosine. If I go to my unit circle, I recall that cosine is going to equal 0 at pi over 2 and at 3 pi over 2. So then my secant value is going to be undefined. So once again then, we'll go ahead and we'll get our 4 equal intervals. Period is 2 pi, half of that is pi, pi over 2 for the first quarter, and 3 pi over 2 for the other quarter. So I have asymptotes here occurring at pi over 2 and at 3 pi over 2. And then you'll also notice I have filled in where my cosine value is equal to 1 or negative 1. So at 0, my cosine value is equal to 1, so secant is also 1. At pi, it's equal to negative 1, and at 2 pi, it's equal to positive 1. So then what I have, again, asymptotes are fences, things that I'm always getting closer and closer and closer to. And once again, in green here, I could draw my cosine graph. And you'll notice once again that the cosine max becomes the secant min. Here's the max, it becomes the secant min. And then here's the cosine min, it becomes that secant max. And you'll also notice, I didn't write this down, but I'll write it down here in just a moment, but that my secant asymptotes are where my cosine x-intercepts were. All right, so let's just fill in a few things then about both of these parent graphs. My range is going to be all real numbers. There are not going to be any x-intercepts at all. The period, just like the old graphs, the sines and the cosines, the period is 2 pi. This is going to be a little different since there is no max or min, true max or min values, absolute max, absolute minimum. Then what we find is that we also have no amplitude. The same thing is going to be true for the cosecant parent. My range, you know, a moment ago, I am just now realizing I said that my range was all real numbers. I was not paying a bit of attention. I apologize for that. My range is not all real numbers. My range has a break in it where the old sine or cosine graph was. So my range will go from negative infinity to negative 1 and then positive 1 up to infinity. I apologize for that. So it's going to be the same for the cosecant graph. I skip over that spot for the old sine and the old cosine, depending on if it's a secant or cosecant. No x-intercepts. Once again, the period is 2 pi, and there's not going to be a true amplitude because I don't have an absolute max or min. Some techniques for graphing. You just simply want to graph the 5 major values of the partner graph. So this is going to be of the sine or the cosine. Sketch any vertical asymptotes wherever there were going to be x-intercepts. And then lastly, you just want to draw your U-shaped pieces between the asymptotes. The maxes of sine or cosine are going to become mins of secant, cosecant, and vice versa. All right, so let's just jump right on in to what we know here. So you'll notice I've got y equals 3 times the secant of 2x. Now, I still need the amplitude of the partner function. So that's why I wrote here that I'm asking you for the cosine amplitude. I will never ask you for the secant amplitude, but I can ask you for the cosine amplitude or the partner amplitude. And so that's going to be 3. The period is going to be 2 pi over 2, which will reduce to pi. So in order to graph a secant graph, all I need to do is go ahead and map out my 4 equal intervals, use the ending for period from the period. Half of that is pi over 2, half of that is pi over 4, and then I can count 1/4, 2/4, 3/4, and 4/4 for the last one. My cosine amplitude is 3. All right, so what we're going to do is, since the partner graph is cosine, just graph your 5 major values as though it's a cosine graph. So cosines begin at the maximum. It also ends at the maximum. The minimum is going to be in the middle, and my x-intercepts will be at the quarters. Well, wherever I have x-intercepts, this is going to be my secant asymptote. And then wherever I have a max, a cosine max, it's going to be a secant min. And wherever I have a cosine minimum, so this would have been at the bottom of my cosine graph, it's going to end up being a secant maximum. All right, let's take a look at another example. So this one's going to be a cosecant example. My sine amplitude is going to be 1/2. The period will be 2 pi over 1, which is just going to be 2 pi. And the phase shift will be to the left, pi over 4. So we'll go ahead and get our 4 equal intervals. Period is 2 pi, so that's where it's going to end. So get half again, and then you can count 1/2, 2 halves, 3 halves, 4 halves. Go ahead and mark your sine amplitude value. So we're going to go up to 1/2 and down 1/2. And then we'll treat this as though it's sine. So you remember back in the sine section, you get your sine major values, and then you shift them. So we're not going to worry about shifting right now. Just get the sine major values. So sine begins at the origin, then it goes to the maximum, back to the x-axis, minimum, back to the x-axis. So these are the 5 major values then for my sine. But now let's take those major values and shift them to the left, pi over 4. All right, if 4 blocks is pi over 2, half of that, I'm going to do this in a different color, half of that is going to be pi over 4. So that basically means that all 5 of my major values are going to shift 2 blocks to the left. Now, remember, my x-intercepts, so that's going to be the beginning, the middle, and the ending. When I shift them to the left pi over 4, I'm not going to draw an x-intercept. I'm going to go ahead and switch over to my cosecant graph, so I will draw an asymptote. So this guy, let's shift it to the left 2 blocks, and when I do, I will draw an asymptote there. My middle one, let's shift it to the left, but when I draw it, it's going to be an asymptote. And then my ending, let's shift it to the left 2 blocks and draw an asymptote. All right, my maximum, which was on my sine max, let's go left 2 blocks. And this is now going to become my cosecant min. My sine minimum is now going to, I'm sorry, I was circling the wrong thing. Here was my sine minimum. Let's shift it to the left 2 blocks. And now it's going to become my cosecant maximum. And then the only other thing I have to do is just make sure that all 5 of my new major values are named. So I have negative pi over 4. I've already marked pi over 4. And then I can really just count because every 2 blocks is another pi over 4. So we have 1/4, 2/4. This is going to be 3/4. 4/4. Here's 5/4. 6/4. 7/4. All right, so that they are all named. All right, then some extra examples. Okay, so as we look at this one, once again, we're not going to ask what the secant amplitude is, but we will ask what the cosine amplitude is. So it's 1/2. Period is going to be 2 pi over b. My b value is pi over 4. So 2 pi over pi over 4, multiply by the reciprocal. Your pi's will cancel. And you're left with a period of 8. So I can go ahead and mark out my 4 equal intervals. My last interval is going to be 8. Half of that will be 4. Half of that will be 2. And then I can count 2, 4, 6, 8. I'm just going to make one block here equal to 1/2. And the last thing I need to talk about is my vertical shift, which is coming from my C value out here. So my vertical shift is going to be down 2 units, down 2. All right, so let's go ahead then and map out our cosine major values. So we remember that cosine is going to start at a max, and it's also going to end at the max. Cosine middle becomes the minimum. And then I have x-intercepts at the 2/4. So now I'm ready to shift. And I'm going to take all 5 of my majors and I'm going to shift them down 2 units. Down 2 units. Okay. So remember that a block was worth just a half a unit. Okay. And I need to shift all the way down 2. So just keep that in mind. All right. So my asymptotes are going to be at 2 and 6. And when you shift asymptotes down, they still look like the same asymptotes that they did originally. All right. Now let's take our cosine maximum and let's shift it down 2 units. So here's a half a unit. So here's 1 whole unit. Here's 2 whole units. So this is where my new cosine maximum will occur. Now it's a cosine maximum, which means that it's going to turn into a secant minimum. A secant minimum. Sorry, I picked the wrong. Okay, so we're going up from there. All right, then you had your cosine minimum. Let's go down 2 units. So here's 1 unit and here's 2 units. This is going to turn into a secant maximum. It was a cosine minimum. And then last, we had our cosine maximum. Let's go down 1 unit, down 2 units. So you're going to land right here. And draw. Okay. All right. Now, this is one where you notice that I need to factor out that B value. Okay. So anytime your B value and your X are connected like this, you need to factor the B value out of both of these terms. So that's going to be the very first thing that we want to work with here. So when I factor that out, I'm going to have 3 minus 4 times the sine of 5 halves times the quantity x plus 2 pi over 5. Now, I didn't show my work on this, but just remember that factoring is done by division. So the math on this would have been pi divided by 5 halves, and then I would have multiplied by the reciprocal, which is how I got 2 pi over 5. Also, remember that the way that you can always check your work is to redistribute. So when I redistribute, the 5 halves times the 2 pi over 5 should give me this right here. This is the best way to check your work. All right, so now let's go ahead and list the things that we know. My amplitude is going to be 4. This is truly an amplitude because this is a sine graph. So it's truly an amplitude. Also, that 4 is negative, so I'm going to be reflecting over the x-axis. The period is going to be 2 pi divided by 5 halves. So 2 pi divided by 5 halves, when you multiply by the reciprocal, is going to become 4 pi over 5. My phase shift is now going to come from here, so it's going to be left 2 pi over 5. And then lastly, we have a vertical shift, and that vertical shift comes from the 3 that's written out in the front. So we're going to be shifting up 3. All right, so let's go ahead then and start graphing. So we'll get our 4 equal intervals first. And our last interval is going to be our period, so that was 4 pi over 5. All right, half of 4/5 is 2/5. Half of 2/5 is 1/5. And then I can count 1/5, 2/5, 3/5, and 4/5. My amplitude is 3, so I'm going to go by blocks of 2 here. This is a sine graph. So my sine graph begins at the origin, and it has x-intercepts on the beginning, the middle, and the ending. I have a maximum normally I have a maximum at the first quarter, but because I'm reflecting over the x-axis, it's going to go down instead of going up. So I'm going to have a minimum first and a maximum second. So these are my 5 major values. So the next thing we want to do is we want to shift 2 pi over 5 to the left. That's 4 blocks left. And I also want to shift up 3 units. So each value is going to shift 4 blocks to the left and 3 units upwards. All right, so let's take our first x-intercept. 4 blocks to the left, up 1 unit, 2 units, 3 units. So land right here. Then we'll take our minimum, 4 blocks left, up 1 unit, 2 units, 3 units. X-intercept, 4 blocks left, up 1 unit, 2 units, 3 units. So already I can see my sine graph starting to take shape. Next is going to be that x-intercept here. Whoops, I already did that one. Sorry, this one. So 4 blocks left, up 1 unit, 2 units, and 3 units. And then last but not least, your last x-intercept, so left 4 and up 1, 2, and 3 units. All right. Okay, 2 more. I'm going to hold off on the tangent graph. We'll come back to that. Let's do the cosecant graph since that's the section that we're working on. So for my cosecant graph, I need my sine amplitude, and my sine amplitude is going to be 1. Notice that I have a negative in front of my cosecant, so this guy is going to be reflected over the x-axis. The period on this graph is going to be 2 pi over pi. That's going to be 2. My phase shift will be to the right, 3. And my vertical shift is going to be up 2. That's the guy out front, up 2. All right, so the first thing we'll do is we'll go ahead and mark our 4 equal intervals, and the ending value will be 2. All right, so I'm going to squeeze this one in mostly because I've learned my lesson and I've graphed this one a couple of times and kept running out of space. So just be aware that that may happen. All right, so the ending is going to be the period of 2. Half of that is 1. Half of that is 1/2. And then I can count 1/2, 2 halves, 3 halves, and 4 halves. My amplitude is 1. This the partner graph is sine, and so sine, beginning, ending, and the middle, beginning, middle, and ending are all going to be x-intercepts. And then since I'm reflecting, then I can go down first to the minimum, and my other quarter will be up to the maximum. All right, so now we want to start working on the shifts. So when I shift, I want to shift to the right 3 units. Now be careful on this one. Notice that 1 unit is 4 blocks, okay? So if I'm going to go to the right 3 blocks, everything is going to go to the right. If I'm going to go to the right 3 units, everything is going to be to the right 12 blocks. Because the first 4, that's 1. The next 4, that's 2. If I do another 4, that's going to be 3. Another 4 will be 4. And another 4 after that will be 5, etc., etc., etc. Okay? So all 5 of my majors need to shift to the right 3 whole units, which is 12 blocks. But not only do I want to do that, I also want to shift up 2 units. Okay, now before I start doing any shifting, when I shift the beginning, middle, and ending x-intercepts, this is a cosecant graph, we're going to graph an asymptote. So when I take this first origin point and I go 12 blocks to the right, or if I go 3 units to the right, I'm not going to draw an x-intercept, I'm going to draw an asymptote. Now, I could start counting 12 blocks for everything, but what I'm going to do is notice that the distance from my first asymptote to my second asymptote is 4 blocks. So I can do the same thing here. Here's my first new asymptote. If I go 4 more blocks, I'm going to have my second new asymptote. Another 4 blocks, I'll have my ending vertical asymptote. All right, when I take my sine minimum, if I go 12 blocks to the right, that lands me here. And then if I go up 2 units, that's going to land me right here. Now remember, this was a sine minimum, so it's going to become a cosecant maximum. And then my other quarter point, this sine maximum, when I go 12 blocks to the right, it's going to land right here. When I go 2 more units up, it's going to land right here. And it was a sine max, so this is going to become cosecant min. All right. Now, did you notice that the directions said that you should graph 2 whole periods? So just graph where you have the space to graph. Every 4 blocks is going to be another asymptote. So then I can easily just mirror or copy exactly what that first period was doing. Okay, so that would be 2 full periods then. All right, last but not least is tangent. Now, if you do not know how to graph tangent and cotangent, what you should do is pause this video and go watch my tangent cotangent graphing video first, and then come back to this. So I'm going to pretend that you understand how to graph tangent. If you do not, then just like I said, go back to that other video. All right, the very first thing that I want to do with this is I need to factor. So I'm factoring out my pi over 2. And when I take pi divided by pi over 2, I'm going to multiply the reciprocal. My pi's are going to cancel, and that's how I'm left with just a 2 here. Remember that you can redistribute to check your work. All right, the tangents don't require amplitudes. They don't have amplitudes. And so I have a period that's going to be pi over 2. So this has a different formula. And since it's pi over 2, I've actually already done that math for something different, but still I've already done that math. So pi divided by pi over 2 has already been done. That's how I knew it was 2. My phase shift is going to be to the left 2 units. So let's go ahead then and mark our period. We'll get our 4 equal intervals. Now, the tangent period is totally different than the other 4. So once again, if you don't understand what I'm talking about here, please go back and watch that other video. But the first period is going to land on 2. But since this says to graph 2 periods, I'm going to simply double this, and my second period will land at 4. So go back to that middle value, then take half, and you'll get 1. And then you can count 1, 2, 3, 4. Remember that my tangent asymptotes occur at the quarters. So what I'm going to do, this is pre-shift. I'm just going to draw some really light asymptotes at the quarters. Not only are the asymptotes at the quarters, but the beginning, middle, and end are my x-intercepts. And then what I'll do is I'll take each of those and shift them to the left 2. Well, you notice that 2 units is 4 blocks. Okay. So this first x-intercept, let's go 4 blocks to the left. My first asymptote, let's go 4 blocks to the left. My next x-intercept, 4 blocks to the left. My next asymptote, 4 blocks to the left. Now this is interesting because the old asymptote landed on top of the new asymptote landed on top of the old asymptote. And then last but not least, that last x-intercept, let's move it 4 blocks left. Tangent graphs are uphill. And already, because of the way that we draw our tangents, this is 2 full periods, where this right here is my first period, and then this right here is my second period. All right, that wraps up this video.